Transistors? There is no electronic device where transistors are not used. The main function of a transistor is switching. A transistor can turn on and off about 1,000,000 times per second. Transistors are the main architect of the electronic world, becoming so modern. In today's video, we will learn how transistors work. Let's get started. What you see on the screen is a BJT transistor, model number BG557C. BJT transistors are mainly of two types, PNP and NPN. Transistors that have N-type or negative semiconductors on both sides and P-type or positive semiconductors in the middle are called NPN transistors. Again, transistors that have P-type or positive semiconductors on both sides and N-type or negative semiconductors in the middle are called PNP transistors. In today's video, we will learn about how the BJT PNP BC557C transistor works. Let's get started. Transistors basically have three terminals. These are called collector, base, and emitter, respectively. Current enters the emitter of the PNP transistor and exits through the collector. The flow of this current is controlled by the middle terminal, i.e., the base. It is worth mentioning that the BJT transistor is a current control transistor. That is, the transistor is controlled by giving or not giving the base current to the BJT transistor, or by giving less or more current. The base current IB controls the collector current IC. Let's now open up the transistor and see what's inside and how it works. As I said earlier, there are layers of P-type semiconductor on both sides and an N-type semiconductor layer in the middle. Now, we need to know very well what these P-type and N-type semiconductors actually are. Let's look at that first. The most used and popular semiconductor is silicon. So, in this video, we will discuss silicon semiconductor. Silicon has a total of 14 electrons. There are 2 electrons in the first orbital, 8 in the second orbital, and 4 in the last orbital. A silicon atom shares 4 electrons in the outermost shell with another silicon atom in a covalent bond. Therefore, pure silicon does not contain any free electrons. As a result, no electricity can flow through pure silicon. That is, pure silicon is an electrical insulator. Let's now see how this silicon can be made electrically conductive again. Look at the periodic table again. Boron has 5 electrons and phosphorus has 15. From the electron configuration, we can see that boron has 3 electrons in its outermost shell and phosphorus has 5 electrons. Now, by adding a certain amount of boron and phosphorus to pure silicon through the dropping process, it can be made superconducting. Let's now analyze the situation after mixing. A boron is placed between the silicon atoms around it, so a hole or gap will be created here for an electron. Because the number of electrons in the last orbital of boron is 3, 4 are required to form a bond. That is, 1 electron is still required here. In such a situation, silicon is called a P-type semiconductor. Again, phosphorus is added. Then there is a free electron that does not participate in bond formation. In such a situation, silicon is called an N-type semiconductor. Therefore, the case is that the P-type needs 1 electron. On the other hand, the N-type has 1 electron more. Now, electricity can flow through this silicon semiconductor. Therefore, we showed at the beginning of a video that pure silicon is non-conductive. Again, silicon can be made conductive by mixing boron and phosphorus in sufficient quantities. However, it is not a superconductor of electricity. It is a semiconductor. That is, a semiconductor. Let's go back to the transistor. phosphorus is dropped into the p-type. As a result, there are a lot of free electrons in the p-type. Again, boron is dropped into the n-type. As a result, there will be a large electron deficit in the n-type. Now, due to the presence of p-type semiconductors on both sides and n-type semiconductors in the middle, a chemistry occurs near this joint layer of the transistor, which is called p-n junction. Understanding the p-n junction is essential to understanding how a transistor works. Let's get started. We have already learned that the transistor has two layers of semiconductors, p-type and n-type. P-type has a lot of free electrons. N-type, on the other hand, lacks electrons. This is why, due to the attraction of the electromagnet, some electrons enter from the p-type to the n-type, due to which a gap or wall is formed here. This is called a p-n junction. Now, even if they want to, the next free electrons will not be able to move forward because of this p-n junction, as long as any voltage is applied to the transistor. Again, here comes a question. What is the minimum voltage required to overcome the wall of this p-n junction? And that is 0.7 volts, meaning that the first wall can be overcome only by applying 0.7 volts to the transistor. Let's create a circuit using transistors and see how transistors work in a circuit. There is nothing to introduce in the circuit. Here is a bulb, a transistor, a base, a switch, and a 12-volt battery. Now the electrons from the battery will go directly to the emitter terminal and accumulate, and some of the electrons will enter the base layer. Now, let's turn on the switch on the base terminal. Now, electrons from the battery will enter the base layer through the resistor and the base terminal. As a result, the electron deficiency in the base layer will be filled, and the entire transistor will now turn on. That is, current will now enter through the emitter, pass through the transistor, and exit through the collector, and the load connected to the collector will turn on. We have used a bulb as a load in this circuit, so now the bulb will stay lit. I have tried to explain with my little talent how the transistor works. If I have given any wrong information, I hope you will point it out in the comment box. Thank you.